There's probably somebody that I'm forgetting because I'm forgetful. So anyway, as I was saying, welcome to the Omaha Java Users Group. I'm Matt Payne. It's great to see you all here tonight. We have 3 talks. I'm going to be talking for hopefully 15 minutes, and then Seth is going to talk for 15 minutes, and then we're going to have Tyler, the CEO of Codenvy, do the, as far as I know, the first ever remote presentation. Now, Codenvy is very interesting. I invited them to come, and the reason why I invited them to come is because they're based on Eclipse Che, which is this GWT-ified Eclipse IDE thing that supposedly you can download and run yourself. I haven't tried it. And they deploy their stuff to Docker, which is very exciting. Everybody likes Docker. Docker, Docker, Docker. And my favorite part, they're free until you get tired of it only running for 5 minutes before you have to restart it. And then you give them $12 and it runs for 20 minutes until you have to restart it, and you have a lot more RAM, which is really nice. The $12 level is worth skipping lunch. And they also have all these canned examples that are really nice. So if I want to play with a canned example of an Angular app or a canned example of a Java Server Faces app, because you know that's the up-and-coming technology, Java Server Faces, it's the bomb. It's right there, and I can pull it up and play with it. So Tyler's going to talk to us starting at 6:45. And what I'm going to talk to you about is a bait and a switch. So here's the bait. SonarQube is so cool, they spell it with a Q. SonarQube is this awesome thing. SonarQube should be part of your New Year's resolution set. SonarQube is like your own personal copy of effective Java right there on your desktop saying, now, don't use bland exceptions. They don't carry enough information. You need to inherit from exception-based class in order to be more clear about what's going on. It's really lovely. Okay? And it's actually pretty quick to get started. What the SonarQube people have done is a very, very clever thing. They've taken PMD and find bugs and all these other static analyzers and all these other things under the sun, and they've made it easy to use. And you know, one of the things that I learned in grad school all those years ago was the technology acceptance model, where the likelihood that a technology is going to be accepted by someone is directly related to its perceived usefulness. Hey, it's like Joshua Block on your shoulder telling you what to do, telling you how to be a better coder. And you can run it on your desktop so none of your managers have to know and come and say, hey, I see you have a code quality rating of C. What's with that? It's,
yeah. Unless you work in UP.
Oh, maybe they already have it then. I don't know.
It's a requirement.
Oh, okay. Well, that's nice. So they really use SonarQube at UP?
Sure do.
That's highly entertaining. Interesting. And then the perceived ease of use. It's amazingly easy to use. There's 2 pieces, you run them, you're done. And then next thing you know, you're in a maze of twisty passages that all look the same. There's lots and lots of buttons. And since this is a lightning talk, we won't go into that very much. But I can easily be persuaded to give you a much more fully featured talk, perhaps with someone from UP, where we explore things like using code coverage tools with SonarQube and all of that kind of stuff. I also want to try and sweet talk you into some other New Year's resolutions. To learn more, to connect with each other more, to be in community more, and if you want to take some of those ideas that you have that are exciting and go to a place where you can practice public speaking, not just general public speaking where you talk about whether the carbon tax is a good thing, but the good kind of public speaking, where you talk about how tries are an efficient data structure to other people who could appreciate that tries are an efficient data structure. New Year's resolutions that are better than all of this grow hair and eat right and exercise stuff. So, hey, there's a video call started. So SonarQube is all about pumping you up. It's like Joshua Block right there on your shoulder. You know, the rent is not too damn high, you just need to do it. There's two pieces. You download this one, you run it in console mode, boom. That's a little web server that listens on port 9000. You can go and click around and see everything. And then you run the runner, which scans through your code and does the static analysis, inserts the data into the server, and you're great, you're good to go. I might decide to violate the rule. And with SonarQube, you can go in and you can say, I like that SonarQube starter set of rules that you gave me, but I want to make, because I don't want to spell my log4j variables capital L, capital O, capital G, because no one in my group does that, and they'll all laugh at me if I start. So I can change the regular expression in that rule and have my loggers spelled logger instead of log. Okay? So what else to show off in here without being too... Here's a really nifty thing. You can go find Nemo on the internet where all of these different open source projects are being analyzed with SonarQube, and you can click around and have a good time and see what they're doing and whatnot. So that's the super quick lightning version of SonarQube. So now let me ask you about the New Year's resolutions of learning more and connecting and collaborating more. So last summer, I went to Des Moines. It's an exotic land that's east of here. And in Des Moines, they have these things called coding dojos. And they're amazing. You meet at this restaurant, and you do a little small talk, and the wait staff brings you your food, and then during the meal, somebody starts talking to you. They say, hey, here's this web app, and it connects to this REST server, and your challenge tonight is to integrate offline storage, so if the REST server is down, the web app still displays the data, and everything works fine. And then you go another night the next month, and they'll have a set of code that's based on changes that people made during the first challenge. They've taken those pull requests. And then they'll have another challenge, perhaps geolocation. So let's try it. It'll be awesome. Let's try it together. Let's try it separately. You can have your own little group. I can have my little group. It'll be great. It'll be totally experimental. We'll see what happens. So I have recruited someone who I respect very, very deeply to partner with me on this project, this experiment, and connecting with each other and learning more through collaboration. Sandy Barr, back there, founder of Omaha Coding Women, has agreed to partner with me on this. And we're going to do this thing that I like to call LocalOmaha.org. And the reason why I like to call it LocalOmaha.org is because in Toastmasters, Ellen is a member of They're a small group. They have 75 companies. And they remind me of the Des Moines workshops, because in the Des Moines workshops, the app that they built allowed you to walk around the state fair and say, where's the closest funnel cake? Where's the closest beer? It had geolocation in it, and it had offline storage because the cell phone reception is cruddy at the Iowa State Fair. And so I think to myself, hey, Ellen would like it if there was a really simple web app where people could say, where's the closest locally owned bakery or bar or coffee shop or whatnot. And so Ellen said, yeah, you can use our data. So yay, we've got some data. And let's build this lovely AngularJS web app that's backed by a REST API where maybe you can do some ratings. And let's do it together and let's get creative. Let's implement Brad's idea and let's implement Ryan's idea and everybody else's idea and just see where we go. It'll be a grand experiment of forking and pull requests and general chaos. So soon it's going to be released on GitHub. We'll send out. Sandy's been working on a nice starter app in the Des Moines tradition. You know, all I've been doing is parsing and cleaning data, you know. So once it's out, you can check it out. You can read ahead. And Rebecca Stavik, I should have practiced her last name. Rebecca, yeah, from Open, Nebraska. She's really nice. She connected us up with a room in Omaha's Community Engagement Center on Saturday, the 7th of February for a little hackathon. We might have a meeting before that. We might, you know, sweet talk the mobile web group into playing. We might sweet talk, who knows, I think Omaha Coding Women might have a meeting around this in February, perhaps. Yeah, there you go. And it's going to dovetail nicely with the talk in OJUG in February, which is about Angular and working with Java security. So one of the things I want to challenge you all to do as part of this connecting together and collaborating to learn stuff is to flip it. We're all very, very used to showing up at a user group meeting and you get a talk from scratch where you walk in and you're a blank slate and Jessica tells you all about test-driven development and it's totally awesome and you didn't have to read ahead a bit. And then, like we all did in college and high school, after you receive the lecture, you go home and you do the homework. Well, flipping is really popular these days in lots of classroom settings. It's where you sort of do the lecture ahead of time, and then when you come to the meeting as a group, you collaborate, you break into small groups and you work on problems and you do pair programming. So my challenge to you is, hey, check out the PhoneCat tutorial app from the Angular folks. It's free. Also free is codeschool.com's Angular class. Google cut a deal with them where it's free for everyone. Now, codeschool.com, they're drug dealers. They will try to make you a paying customer. It is wonderful to be a paying customer of CodeSchool. I tweet whenever I achieve a level. I like being a paying customer. Wait! Anyway, you should check out the free class.
I'm still getting emails, man. I need to stop.
There you go. So save the date. You know, it's going to be an Eventbrite because Rebecca from Open Nebraska has offered to buy folks lunch. And the last New Year's resolution is the public speaking meetup group just for software engineers, where it's okay to talk about algorithmic complexity. And it's okay to talk about cyclomatic things. All right, you bring your lunch. It's a noontime meeting on February 11th at CoViz Code Networking, which is near the Interstate and Pacific Street. So that's like 108th and Pacific. And if you go out to where it is tiny URL, speak to code, you get the little meetup thing. Many thanks to Agape Red for buying that. So thank you for listening to me ramble. I know where New Year's resolutions go, and hopefully these New Year's resolutions that I'm trying to sweet talk you into, of connecting with each other more and in collaboration and community learning more, not just the technologies but also each other, so you can say, oh yeah, Kevin, man, I've pair programmed with Kevin, he's freaking awesome, you know, as opposed to yeah, that guy seems really nice, I've never worked with him. You know, wouldn't it be nice to get to know each other some more while we learn stuff? All right. Thanks for listening to me. Next up is Mr. Seth Lachner talking about jClouds. And I don't know how to make it go back.
Click present.
Good. Thanks, man.
It's really straightforward. Thank you. Right on time, too. That was remarkable.
Toastmaster.
All right, so jClouds in 15 minutes. We'll let you talk here. This slide is for people who are not cloud computing knowledgeable. I'll go through it really fast. The whole point: you can get scalable storage, you can get computing resources, you can get some resource management, and it's all for rent in somebody else's data center because you don't want to build your own because they're expensive and they're hard to cool. This is annoying. Thank you. Oops. So what is jClouds? jClouds is this is their quote from the Apache website. It's a multi-cloud toolkit. Okay, what is a multi-cloud toolkit? Essentially, it's a cloud abstraction layer, right? Hardware abstraction layer, database abstraction layer, cloud abstraction layer. They even themselves use the analogy JDBC for cloud providers. That's an okay analogy. It's not great. It's an Apache project, and with all that implies, it's got a fairly high level of polish, and the documentation is pretty good. So. Well, vendor lock-in is a real problem, especially when you're doing something in the cloud, right? As soon as I code heavily to Amazon, I'm kind of stuck there, and Amazon is happy about that. Amazon doesn't want me to ever leave, even when they have an outage. And they do. These environments, for as amazing as they are, they fall down, and it's a problem. One of the things we're always trying to avoid when we're writing software is we're trying to avoid repetitive code. Well, if I'm writing to Amazon's API, and I'm writing to Rackspace's API, and I'm writing to DigitalOcean's API, you better believe I've written the same code 3 times, just slightly different. Why would I want to do that? Finally, one of the really cool things that I think is awesome about the concept behind jClouds is vendor distributed systems. So I have this I have this idea that I can actually take a system I've developed and deploy it on multiple clouds and have them talk to each other. I can do cloud failover, I can do stuff like that because my code is cloud portable. So those are the 3 primary use cases. So jClouds has an interesting abstraction model. It's a kind of a 3-legged stool: provider, view, and API. So provider is kind of a wrapper around a vendor. It's both company or corporation specific like Amazon or Rackspace, and also location specific. If I'm doing Rackspace US versus Rackspace UK, those are considered to be different providers. Providers implement APIs. It's a wrapper around the vendor API, so it's an abstraction at the API level. And then finally, there's a view, and a view is a high-level construct that implements the API as well and is informed by the provider. So, wrap your head around. So what does all that mean? So, the top level, the red level, are the 3 views. We'll get into those in a second. jClouds API below, vendor-specific APIs, and then off to the left we have the providers. And this is roughly kind of what I started keeping in mind in the documentation. And then, of course, on the far right, you can punch down through these layers. The whole system is designed that you can get to what you need to get to. As they say, you can unwrap a specific layer as you need to, so that if you actually have to make what you need to do on your system, that's available to you. And they do provide a method to drill down and get there. So we'll talk about the 3 views real quick. There's the blob storage view. So there's this idea that I'm going to have a specific abstraction, a high-level abstraction for data storage. And the idea is, if I'm not doing anything really sophisticated, I can write to this view, and this view is very, very portable across vendors. They have a common context construct, which I'm going to be able to use in blob storage, I'm going to be able to use in the compute engine, I'm going to be able to use in all the views. And then it's going to provide management for the binary objects or the object storage. It's going to provide container management. And this concept of container is essentially like a high-level directory. It's going to provide folder management, which is a jClouds construct. And this is where it's kind of interesting, right? Not all these constructs are on all the providers. So some of these are going to be virtualized. A folder is essentially a subcontainer in the jClouds lingo, and that may or may not be available on a given vendor. So what jClouds will do is jClouds will virtualize that for you. It provides access control because, of course, cloud services are all about access control. There's key management, there's password management, there's all kinds of stuff that has to occur. And then there's path virtualization. And again, this ties directly into the overall abstraction layer. You can't, because the paths are different across each of the vendors, you have to have some kind of virtualization to be able to deal with that. The other primary high-level view is the compute view. So this is actually deploying virtual machines. This is deploying software. This high-level view is all about abstracting that away so that you don't have to write too much code to the specific vendor level. It shares the same common context with the blob store, with the data storage view, and then it provides several high-level services. It provides template abstractions for virtual machines, so you can define these virtual machines in as abstract a manner as you can work with, and those abstractions will build out automatically, kind of like to like on the different service providers. So you may be specifying one flavor of Linux on Amazon, and that flavor of Linux might be slightly different, but compatible on Rackspace. They provide some very interesting node management hooks, right? So you can stand up your nodes in singles and groups. You can manipulate them as single nodes or group nodes. They have these predicate commands to let you kind of do nodes like this, do this command kind of situation, kickoff scripts, things like you would do in a data center environment. They provide a metadata abstraction for nodes, which is basically the properties, right? So basically say, hey, I want all the properties for this node or for this group of nodes. You can pull those down. You can dig through them and find the things you need to find to figure out what's going on in your systems. And then, of course, if you can read those properties, you can set them as well, which is a node configuration. There's a load balancer view, which is currently in beta. There's not much information on the website about it, and there's even less available unless you're willing to dig into the kind of the pre-release source code. It's under development. So the idea is that this will provide a high-level abstraction for managing load balancers where they're available in a particular vendor. So you can stand up a load balancer, you can add nodes to it, you can perform configuration of that load balancer. I don't have any information on when that's going to be done, but it's featured on their website. If you go out to the website, there is a great set of examples in their repository. Seriously, they're very easy to read, and they're fully runnable. They have in-memory providers. You don't have to, the cool thing is a lot of this stuff is stubbed out. You don't have to get out your credit card to play with this. You can run it on your local machine and it'll pretend that it's actually connecting to Amazon, it'll pretend it's actually connecting to Rackspace, and so you can play with the code without spending money. The documentation is pretty good. I think the examples are better. It gets into some conceptual and practical level documentation, and then it does do a dive cloud provider specific information. And then of course they have extensive Java docs. And those are probably the least useful when you're first getting started, but they are available. As far as supported cloud providers, they hit all the high ones. So you know, we got your Amazon, we got your Rackspace, we got OpenStack, Google Compute Engine and Cloud Platform, those are all covered. I'll talk fast. I did have, this is, since I have a few extra minutes, this is a sample of, code off of the Apache website that describes at a high level how to initialize blob store connection and actually load data. It's very easy to follow, and it's pretty straightforward. I'll just leave that up there if you want to look at it. Does anyone have any questions? Okay, thank you very much.
Thanks, Seth. So there's this guy in Massachusetts who has this series of meetups called Free Big Data Workshops or something like that. And I think his materials are Creative Commons licensed or some other kind of open source. And you know what the church lady would say. How convenient. So, up next is a bold experiment here on this tab. Hi, Tyler. We're supposed to start in 3 minutes.
Did you mute it?
Maybe that's what's wrong.
Yeah, it looks muted.
Oh, good. Hi, guys.
No, you just muted.
No.
No, you did just mute it.
Unmute the microphone. So we're not muted. They're just
Oblivious.
No. We're early and they're on time. So I'll just call the guy with the really good hair. It's gonna be a really good talk.
You think?
Hey, Michael. Hey, it's Matt. So we're early, and I'm failing to get Tyler's attention.
Maybe he's got it on mute.
I think I have the same. Wait. I bet it's operator error on my part. Hey, can you hear me now? No? We practiced this. Remember, we practiced this. This is the same laptop.
Is it Tyler?
No, and he just went to his circle. We're getting all our experts up here to try and help. I grumble.
Kill that presentation.
Do you want to? Maybe that's it. Maybe we got a piece of software that's fighting it.
Where are you headed?
Well, crud. How about if I quit Chrome and come back in? What do you think of that?
Hey Matt,
Oh,
check which microphone it has input on the voice. It likes to play.
okay. Hold on a second. Yes, it was. How do you check the microphone?
Under the gear in the middle.
And help me out. Sorry about this, Mike. So it looks like it's the internal microphone.
Yeah, but he's talking about.
He's talking about in the browser.
He's talking about in the browser.
Like there.
Right there.
Default. Okay. Built in. And all right. Is that better? No. How about if we get out of the Hangout and try coming back in? All right. Sorry about this, guys. It's Murphy's Law. People are getting more pizza. Maybe that's what they're doing.
So now we're on time.
Yeah. 4 minutes. Notice it's ringing.
Oh, hey, we have sound.
All right. Thanks. Bye.
Great.
Hey, it's great to see you. Can you hear us?
Yes.
Good.
Can you hear me?
Yes. In the back, we're good? Okay, good. I hope this goes well. Otherwise, I'm going to have like 46 people giving me the stink eye. So, Tyler, you're going to introduce yourself, but my understanding is you're one of the primary minds behind Codenvy.
Yes, the founder of the company.
Excellent.
Let's see here.
Try and get the AV just right with the full screen mode. And
Where's the mouse down?
All right, I'm able to see all you guys. You were very animated walking around for the past 30 minutes.
yeah, can you see the crowd so you can see how happy you're making them?
All right, everybody wave.
There you go.
There we go. Good evening. All right, cool. Are you able to see my screen, by the way?
Just you.
All right. Great. We can make this work. No problem. All right. Share my screen. Okay. How's that going for you there?
Good.
Yay!
All right. We got about 30 minutes or so. Is that right, Matt?
Yeah, 30 minutes or so. That's fine.
Okay, cool. Well, it's I've been to about 20 or so jugs in the past year, so I really enjoy participating in these sessions. It's really kind of touching and compelling to me to see how active and engaged the Java community is after what is nearly 20 years now. A little bit about my background. I studied computer science. I tried to be a software engineer, but I've spent most of my career in product management, general management, and investment. My very first job out of school was in the 90s, and it was as a Java instructor for corporations. I get to travel around the world and teach people about Java and JSPs and Java EE. And that consulting company was acquired by BEA. And I had a good time. I got to spend 6 years at BEA. I spent most of that time in marketing. I became their chief evangelist, running their developer relations programs. And while I was there, I'd written 3 books on Java. Mastering EJB, Java Web Services, and another one on Java EE. And it was a good time. After BEA, I spent 2 years running the server side before we sold it to the Tech Target. At that point in time, it was a subsidiary of Veritas. That was when the community was about 500,000, and we always likened it to a little bit like a tabloid journalism for the Java market, and that was a lot of fun. But then I spent 7 years at a great company called Quest Software. They were focused on systems management. And they were primarily in the systems management and monitoring identity space. And so it was a pretty big departure away from Java and middleware. I never quite felt at home there. And so when I was done, with Quest, I took a short sprint at Oracle as a VP running their public cloud. But things had already started, really nagging on me. That it felt like development tools had gotten too complicated, and that there had been a lot of fragmentation of programming technologies over the past decade, and that there was something making this technology a little bit more difficult than it needed to be. So at that time, I got started investing. Doing investment work for a venture capital company called Toba Capital, and working with another guy, a French guy, Benjamin Mastralet, who's the founder of Exo Platform, and we had been tinkering around with ideas relating to Cloud IDEs, and we felt like that there was going to be a pretty significant problem out there that we could solve, but we had to fine-tune it and figure it out. And we eventually did that and created the company Codenvy here. Before I get into Codenvy, I do two jobs. I'm a partner at Toba Capital, which I've been with for 3 years, and I'm the founder and CEO of Codenvy. But at Toba Capital, all I do is invest in developer businesses. It's a personal passion of mine. I have an investment thesis around developer technologies that is pretty expansive and long range. The companies that I'm involved in, I'm a board member and investor at WSO2, Sauce Labs, which makes a Selenium test cloud. Let's see, Shift Mobility is another one. I'm just an investor at some other companies. InfoCube, I'm a founder investor there. I've been invested in that for 10 years now. Zero Turnaround, which makes the JRebel product as well. SD Elements, which does security technology for Java developers. So pretty active and engaged there. So Codenvy. I'm going to do just a couple of slides about what we're about, and then I'm going to get into the Payne and spend the rest of my time with demos. We started the company really in 2012, but it officially incorporated at the beginning of 2013. We've got 150,000 users online. It's pretty good. We're growing a few thousand each month. We've been pretty stealth for the most part, believe it or not. We've got a couple of products. I'm going to talk about them. There's a SaaS product which anybody can use for free. Also, everything that we're going to show you runs on-prem as well. So we have some large enterprise customers that deploy us and run us for their own cloud purposes, like Boeing and Intuit there. And life's pretty good. So, what was this view of the world? Essentially, our view is that application development has changed over the past 15 years. And the transition, Gartner really said this nicely, in that the transition to Agile, DevOps, and web-scale IT practices is going to become as disruptive to IT as lean manufacturing was in the 1980s. And what do they mean by that? And really, there are two fundamental trends that are going on that are affecting developer productivity. The first trend is an architectural one, where we slowly migrated from free-tier to composable services. And I guess the trendy thing to call these are microservices now. But the big distinction between free-tier and composable services is that there is a much more complicated dependency map that exists. Each microservice is independently deployable, it's independently managed, and it operates on a life cycle that is autonomous from the others that are there. It has a downstream and an upstream dependency map, and some of those dependencies may come from open source modules. And so as you move to composable services, by definition, the number of services that you depend upon increases, and as they increase, the configuration complexity of the system as a whole increases with the dependencies as well. So if you're a developer and you want to set up an environment to develop in one of these kind of microservice dependency maps, you have pretty much three choices. You could do manual configuration, which is step-by-step, administrative, and something we've all experienced. You can use a desktop box, which is fairly expensive relative to other options and fixed size. And then virtual machines are large and they're slow, and you have to synchronize them over time. The second wave of what's going on is something that we've coined, and we see that the world is moving away from a very insular contribution structure to a very open one. If we were to go back and look 10 or 15 years ago, most development projects were done by a team, and the entire team were the only committers to that project, and there were no outside contributors to that. And so when you have that sort of insulation, you can come up with a very proprietary process. The domain knowledge is kept very isolated to just a few people, and they can be highly productive with each other, but if you're an outsider, you're really not able to contribute unless you can become an insider. Due to the advent of open source and the successful models with Bitbucket and GitHub, contributions are becoming open, where not only can the team provide these contributions, but you accept contributions from your users, and you accept contributions from the dependencies that are upstream and downstream as well. And so what happens is that if you really want your project to be successful, you need to open yourself up. And what happens is that the committers on the project, in order to get contributors or your passionate champions to be able to support you, you start spending a lot more of your time providing support and review to the contributors and a lot less time making contributions of your own. So this open model allows you to potentially be more productive, but at the cost of setup and configuration time for your trusted inner circle there. So I told you guys that I went away from programming for a while, and in 2010, when we started talking about creating Codenvy, I came and I wanted to get my Java skills back, and this tutorial was what I was faced with while setting up Eclipse in Tomcat 7. So here's the world's most popular application server running with the world's most popular IDE, and this was the quick start guide there. And this was just kind of ridiculous. And you know, I remembered all my skills and I knew what I was doing here, but it was just overwhelming. It took a long time, and there was a number of days before I was coding productive again. This problem is a pretty big problem. The repeated configuration of these developer environments causes productivity loss, and it's in two ways, right? One, there's wasted time that we spend setting this stuff up that we don't need to. But the second time is that your company and yourself, you bought your computer, and your computer is there to compile and run these applications. So if it's just sitting idle, you've essentially overpaid for these resources that are just sitting idle there. So, you know, when you look at the global developer population, there's a number of statistics that indicate how much time is spent configuring, but it gets into the billions of hours wasted time here. So, we built Codenvy, and I'm going to give you a demo here. And the basic idea is, what if you could contribute a tested change or a pull request to any project within a matter of seconds without installing software? And essentially what we do is we make it possible to create, share, and scale developer workspaces in the cloud or on-prem. And we service two audiences, developers and DevOps. Now, with DevOps, the purpose there is it's a little bit like Puppet for the IDE. It's an automation engine where DevOps professionals or team leads or whoever it is can provision workspace replicas that are easy to share and secure to manage. And those workspace replicas, upon continual provisioning there, will always be identical. And you don't have to worry about, did it not work on my machine. And in the case of developers, we built a very fast, non-blocking, non-thrashing Cloud IDE. And the goal here is to let you write your code and then command Docker microservices that are running on horizontally scalable nodes so that you can build and debug for many machines that are out there. So let me get started. Let's see here. Are you still able to see my screen here?
Yes.
Yeah.
Is it zoomed in enough?
No.
All right. Now?
Better.
Better? All right, I'm getting into some pretty max, got like 250% zoom
Yeah,
here.
that's good.
Right there.
This is good?
Yeah.
Okay, so this technology that we're going to show you here, this is not, we've kept this in our alpha labs. We're probably going to ship this sometime in February, I think, here. But this is a system. I'm not logged into Codenvy. I haven't set anything up. This is a repository that we manage out there. It's just a fork of the Spring Pet Clinic. But let's imagine it was the Spring Pet Clinic root repository there. And let's say that I wanted to become a contributor of this repository. What would I need to do to get set up? I would normally need to, install Java. I need to get Maven installed here. There's probably going to need to be a number of libraries that are downloaded by Maven. I'm probably going to need the right set of plugins for my IDE. I'm going to need a Git client. I might need the GitHub client there. I'm going to have to upload a key to GitHub in order to authorize this. And I'm also going to have to fork this repository because I want to do my changes in a branch, test those changes before I submit them. So it's a lot of work there. And if I was working on another project, I'd probably want to stash my work first as well. So instead, I'm just going to click this contribute button, which is a technology that we've got. And when I click this button, what we do is we provision the workspace. I have not logged in. You can, let me zoom in here. Get a little bit bigger here. All right. So is this big enough for you guys, by the way?
Yes.
Yeah.
Is that a yeah? That I hear?
Yes.
Yeah, that's
Okay, great. So this is a temporary workspace, so we provisioned a workspace. That's out in the cloud. It's running at Amazon, either in Europe or North America there. We set up an anonymous user, so I'm logged in as an anonymous user. This workspace was given a resource allocation. In this case, it was given a 0.5 GB RAM down here. It was given unlimited storage, and then it created a project, and it automates the project setup here. So in the project was a clone of that GitHub repo, and so we see that here, and I can open this README in this. And so there's a README from that GitHub repository. It has Maven installed here. I know that Maven's installed because we installed the Maven plugin. This custom Maven build would not be there if Maven was not detected on this. We added an editor. In this case, the editor is CodeMirror. The CodeMirror editor gives you something like 70 different language support. We can do things like code folding on this, syntax highlighting, lots of stuff we can do with this particular editor, including Emacs and VI key bindings. I'll come back to that, but everything's been set up. So if I just click run here, right, in addition to cloning the source code and setting up all the plugins, it's also installed a machine that can be used to run the project, because it's off in the cloud there. And what we use is we use Docker. So every process in the system, whether it's a unit test or a builder or a run or a debug or a Git operation, what we do is we spin up a Docker container, and then we build that Docker container. We call it a machine. We build that machine according to a recipe that is a Docker file. And then after that machine is ready, we inject both the source code and any of the compiled artifacts into that machine so that the machine has access to them. In this case, the machine that was needed to build this project was injected as part of that contribute button. So here's the recipe here. So this is a Docker file. This Docker file says that you're going to pull from a base image, a Codenvy base image that has Java 7. It's got shell in a box, which provides a terminal access. It then downloads and installs Tomcat 8. It exposes port 8080 here. It sets a working directory. It's going to take the WAR file that was compiled, and then it executes this command, which is launching Tomcat there. So it built that on demand here. It actually constructed the machine. After the machine was constructed, it installed the WAR file into it, and it's given us this URL. I click this URL, and Pet Clinic is now running out there. So it's running in that machine that's hosted out in our cloud here. You guys with me so far? You on this?
Yep.
All right. We've got terminal access to the machine as well. Right? So I can navigate the files. But that's not why we came in here. We didn't come in here just to run this. We came in here to make a contribution. So I'm going to open up the file. This is a README. We'll make it a real simple file as opposed to a Java 1. And so this is a contribution. I'm going to save that. So I did that. And then if I wanted to make that contribution actually back to the GitHub project, this is where things would get a lot trickier. I need to go make a fork, and then I need to synchronize my branch fork, and do a lot of setup work. I need to upload my GitHub key to GitHub itself. And why do all that sort of work? So here we can just automate the pull request, and we built this in. I'm going to set this up as a branch. Let's call this the Omaha pull request. And I wish I was having an Omaha steak, which actually is really good steak. And we're going to go ahead and hit contribute. I haven't committed these changes to my local Git repository, so it's asking me to do that. I'll say OK with that. And there it goes. It's getting the key up to GitHub. It's doing the fork. There we go. Boom, boom, boom. And the pull request has been created. And so now we've issued that pull request. And if I go here, what is that? What is that? You know, I know why. This is an alpha bug. I know what the issue is. There we go. There we go. There's our pull request. So there's our pull request, and that's been issued on GitHub. And in addition to the pull request, here's my comment. I wish I was having an Omaha steak here. And inside that pull request is a comment that we provided in here. Build and run this pull request in Cloud IDE. So as a contributor, I haven't installed anything. I didn't deal with any of the dependencies. I got the machine that was there. I was able to compile it. I was able to run it. I was able to make a modification and then issue my pull request. And now if I was a committer on this project, I need to review that pull request. And so by clicking this link, what this does is it's now opening a second IDE instance out in the cloud. And this second IDE instance is completely isolated from the first. And so now I'm acting in the role of the reviewer here, and I can actually build and run the changes that this person made as well, and I open up the README, and here's that contribution on it. So now, without doing anything extra, all the meta information necessary for this developer to build and run the very same thing that you had is snapshot, stored, and kept with that version flow that's there. Let me pause there. Any questions so far? I got more demos. We got lots of stuff to talk about, but I'll come back and open up just initial demo questions on this. None?
No, I think we're good. Yeah. We want to see more.
See more. Okay.
Very cool.
All right. So let's see here. Okay, so how do we do this here? I'm opening up, let me zoom in here. The way we do this is we said that it was a little bit like Puppet for the IDE. So we maintain a JSON format. This JSON format is both a project definition, but also a what we call a factory definition as well. And the factory definition is a set of instructions that are given to Codenvy in the project construction phase. We have a very rich language around this. We publish this language online, and you can write your own files for this. In this sample here, this is a variation on the Spring Pet Clinic here. You can see that it's a Maven project type that installs the Maven builder. It's going to install this Tomcat Docker file as well. And in the source, it tells you where to grab the project source. So it's going to get it from a GitHub repository. It's going to be a Git client. It's going to grab it from the MySQL branch. And this is the location of the Docker container that it came from. If I wanted to, to show how this works, we have a command line client. So everything that you can do in the Cloud IDE, you can do on the command line. And so I'm listed, and these are my projects that I've got. I've got 3 projects. But this JSON file, if I wanted to, I can just create this project, demo2.json, hit enter. And what it's doing is it's taking that JSON file and then creating a project against that recipe. And that recipe has now been created. And so if I go list here, I've got a 4th project. It's the demo02. And then if I wanted to, I could build it here or run it here, or I could just open it. This. And now it's opening that project that we had just created there, which is very similar to the one we had before. This one's a little bit different. This one depends upon a MySQL database instead of a built-in database for the previous one. This allows us to show the flexibility of the editor. So the entire product itself was built on an open source kernel that we built called Eclipse Che. It's donated to the Eclipse Foundation there. This SQL editor that you see is a plugin that was built on top of CodeMirror that allows for syntax highlighting, command execution, data source discovery. I'm not running the program right now. I need to run the app to be able to discover the database. But what I wanted to show next was, let's get into Java. When it comes to Java-specific stuff, some of the things that we do is, one, we have a package viewer, right? So this, we're summarizing the package definition pretty nicely here. I can come here to web and open this Java file. In the Java file itself, we do quite a few things. One, the if you do F4, oops, I just killed that window. Wrong server. Sorry, hold on. Gotta bring up my dashboard. There we go. All right, we're back here. All right, let's get that Java file opening in. All right, so F4 doesn't jump to definition. We've got code folding on this. You've got autocomplete as well with control space here. When we do programming language work the way we're doing it here, what happens is that the first time that there is some sort of work to be done, we process that on the server side. The server side then generates the abstract syntax tree and it sends it back into the browser where it's buffered. So the next time that I hit this, it's automatic there. So the first time there's a little bit of a delay, and on the second execution, it's pretty immediate. There is the syntax analysis. So you can see that I take the semicolon off, and you get the squiggly lines there. You get the icon on the left. There's built-in JavaDoc as well. And there's also a built-in debugger, so you can set breakpoints in here when you run it with the debugger. And you can step in, step two, step through on that. Let's see. So, well, that's getting ready to run. So the way that we do the recipe generation is we do it with what we call a factory here. And at any point in time, you can take one of those JSON files and generate it as a URL. And what this does is that when you have it as this URL, it becomes reusable for anybody who clicks on that URL. So if I were to take that URL, open up an incognito window, paste that URL into this window here, and then execute it, each invocation of that URL is going to generate an entirely new instance of the very same project that's been snapshot. So back here in my main browser, I'm running this. It looks like it's getting booted. I've got 2 gigs of RAM. I'm using 1 full gig here, and this one is running. But when I'll switch back to Yep, here it is. This is the incognito window. I invoke that URL, and now it's put me into a temp workspace, and I get a second copy of it. It's got a ½ gigabyte of RAM. It welcomes me in the window here, and I'm available to do everything that I need to do. I can go ahead and run it here as well. And this one's not going to work because it didn't copy over I didn't have privileges to copy over the runner with it. But if I have the right privileges, you get the perfect clones each and every time with this. I can also take those factory URLs. Here, stop this. Grab the original factory. And you can embed those factories in web pages as well. So if I go to CodePen, CodePen allows you to just run random JavaScript. And I paste that JavaScript into CodePen. Now, inside this web page here is another copy of the very same project that was there. So it's creating another clone, it's setting up the builders and runners, adding the plugins, and it's all set to go. So this all plays to that DevOps methodology that's out there. So define your recipe, provide the recipe out there, and then everybody's going to get the replica that they need each and every time. Stop this. All right. So let me wrap up, and we can open it up for dialogue here, a number of things. The intellectual property that we built, we've got about 40-ish engineers in the company. It's taken us quite a while. This technology that we're running here, it took us 3 years to build, and we put it in production in October here. Prior to that, we had a classic web app. It was a Cloud IDE that we'd run for many years. It did quite well, but it was not extensible. It was not very fast. It was very difficult to maintain. So starting in 2012, when Benjamin and I really wanted to go at this problem in a big way, we designed the system, and the IP that we built was in a number of layers. So at the lowest layers, there is a kernel, and it's very similar to the Eclipse RCP. Its purpose there is to load and unload plugins. And those plugins are essentially extensions that change the way the cloud works. And everything that you've seen here in our cloud, including the scale, are just plugins that have been packaged into it and then deployed into our architecture. We've built about 55 or so plugins. We have them for a variety of languages. We've got them for Maven and Ant. We're working on a Groovy one, which I think will come out in February as well, so that's going to be pretty cool. There's Git, there's Subversion, there's a bunch of stuff that goes along with it. All of those plugins and the kernel is packaged up as Eclipse Che, and it's open source there. You can run that Eclipse Che on your desktop. It is a replacement for the Eclipse IDE, even though it's using Tomcat. So it's a complete browser-based Cloud IDE that runs in a Chromium or a normal distribution there. We then take Che and all the plugins and we deploy it into the automation engine, which you've seen. And then on top of that, all the different atomic operations are provided as separate microservices. So builders are on one cluster, runners are on another cluster, the Git operations are another. We put the data source computation on yet another there. So they're all in these different microservices there, so that the developer has access to an unlimited amount of power. And then we make that infrastructure secure. Projects can be public or private. You can invite users and control the user list, and there's an organizational structure as well where you can have multiple workspaces controlled by a single administrator. We then have a global singleton updater for the installation of this, and then both our public SaaS that we run at Codenvy.com and our on-prem version are all orchestrated by the updater. So you can get new versions, you can keep it in sync, you can get support patches and whatnot from it. Everything here is built to run on-prem, and in fact, you can install the entire cloud on a single CentOS node in about 20 minutes or so. It's really easy. All you do is you just run one command on CentOS, and we take care of the rest on installing the code. The way it runs at scale is there's our updater service where we have the installer, the binaries, the plugins, and support packages. And then behind your firewall, a Codenvy installation manager daemon gets installed, and it acts as a bridge between Codenvy and whatever clouds you install on your own environment. And then for each Codenvy installation that you do, that installation can either be a single node or it can be thousands of nodes. It's your choice in that configuration. We install a Puppet Master, and the Puppet Master, what it does is it stores the Codenvy binaries that are needed. It also stores the certificates, and then it also stores the definition of all your nodes. So node 1 is going to be a builder, node 2 is going to be a code assistant, node 3 is going to be a runner, node 4 is a runner. And so what happens is that these individual nodes, when they boot up, they connect to the Puppet Master, they identify themselves as node 1. The Puppet Master says, you're a builder, and he goes, okay, let me install myself and set myself up. And so it's completely self-autonomous. There's built-in monitoring, there's built-in backup on it, and it runs itself. And when it's all deployed and it's set up, it's actually running an architecture that looks like this, where we do a site, a web server on front with Apache and HA proxy to deal with all the URL management. Then there's a whole cluster of API services for Git, code assistance, the data source work, what else am I missing? Our pinging service. All those are separate API services that run. They connect to the builders and runners. And then all of this is also tracked in a big analytics database where you can replay sessions, track user activity, and benchmark performance as well. So this is actually how we run it at scale and then how it runs on-prem as well. So with that, I'm about 5 minutes over. Apologize for that. The last ask I'll give, and we can do Q&A, is we're definitely opening up the SDK at Eclipse J. I would definitely love contributors there. Happy to provide all the support necessary. There's a number of companies that we're working with, including SAP and Red Hat already. And then beyond that, if you have an open source project and you would like that contribute button on your own project, we will give all of your contributors 4 gigabytes of RAM for free. So when they click that button and it opens up and you get that custom experience, we'll give you a pretty big workspace, and then your contributors can use it for their own work relating to your open source project there. So definitely get in touch with us if you're interested in that. Matt, I apologize for running a bit over there. I find that it's hard to try to explain the new concept of a Cloud IDE concisely. But happy to take any questions and do some Q&A.
Tyler, I have a question. Can you hear me?
Yes, I can. Right. Let me see if I can get my video on here, by the way.
Okay. I'm off the side. I'm slightly off screen. So is there anything in either in the product currently or planned for like remote pair programming?
So we had in the previous legacy version, we had a pair programming capability. We took it out because it was one of those things that everybody asked for but nobody used at the end. We will put it back in, but it'll probably be like a year or so before we put it back in. So the way it works today is that you can actually put as many developers into the same workspace as you want, and it will work just fine. It does have a policy of last write wins. The only thing that we're not doing is we're not showing you the cursors of the developers that are there. Since we have a policy of everything that we put in our public cloud needs to be installable on-prem, in order for us to do this, we have to build an operational transform engine, which is the way Google Docs does their work. And an operational transform engine is basically a queue of requests. So every keystroke gets placed onto a queue, and then there's some mediator service that knows how to deal with the conflicts one at a time. So we're going to have to build one of those, well, to do it at scale and make it installable on-prem. And we know how to do that. We just haven't gotten around to doing that work yet. Okay.
Do you have plans to support Gradle as a build?
Yeah, so you can actually do Gradle builds today because you can build custom machines to do that. But we're building a Gradle plugin that will probably ship in February.
So configuration of the one-click contributions, is that on a project level, or is there some type of browser plugin so that I can do that as an individual contributor?
Is that on a project level, or can you do it as an individual contributor? Can you elaborate a little bit?
Yeah, as a project owner, do I have to set up an environment and configure that? Or could I, as an individual who wants to contribute, set up my environment so that I hook into somebody else's project?
So either way, right? So in order for the contribute button to work as smoothly as I showed it, the project owner would have to have written that factory code, put it on the README there so that it will work correctly. But if you were not that person, right? Let's say I was just here and I wanted to do a new project. I could import project here, and I can import from GitHub, and I can just put that GitHub URL in here, and it will do a clone. But once I do the clone, Codenvy doesn't know what type of plugins it needs. So you have to then go through a configuration wizard, which would be the same as if I did a new project here. And the configuration wizard has you choose the plugin type, the builder type, what machine you need. If it doesn't have the right machine, you can write your own machines using Docker file syntax on that. So it's a step-by-step manual setup if you need to import it yourself on that.
And you manage all the Docker machines, so if I customize the Docker machine, it goes into your Docker repo?
No, that's not quite the way it works. So when you have a machine here, a machine can have different scope. So there are machines which are Docker scope, which are at Docker Hub itself, either in your account or some private account. Okay. And those machines, let me bring this up on with edit this custom environment. So those machines are referenced with the from command here. If you add your own machine, in this case, this MySQL Tomcat machine, which has been added here, is in project scope. And so what that means is that all this content is stored in the project directory, and if the project is cloned, then this goes with it. So we have the concept of machines having a different scope. It can be project scope, user scope, workspace scope, and then the scope dictates whether what the privacy controls on the machine and whether it's cloned or not in a cloning operation there. So if I wanted to create a new project scope, I could edit custom environments, I could add one here. Machine, okay. And we give you some help here, we give you some syntax highlighting on this. This machine is real basic, it just starts from Codenvy shell in a box, and then it runs an infinite loop. If I were to save this, I could then do run with this Omaha machine, and now I'm booting up this project with that custom machine that I wrote there. What do you guys think? Is this interesting, or is this, are we going backwards with technology or going forward?
Oh, that was the other question. So what's the smallest machine I can run this on? Can I run this on a Chromebook, or what do you recommend?
Well, about 5% of all of our users are on Chromebooks here. That browser tab that I'm running, it takes about 90 megabytes of RAM per browser tab. You can have as many of these projects and open as you want, given the RAM of your machine there, of your desktop machine. Once you've got it opened up, you can have as many Codenvy machines running as your account allows. So each machine can be 200 gigabytes of RAM, and we've tested having something like 20 machines running on a single project at the same time. So you can, that was 200 gigabytes times 20. That would be 4,000 gigabytes of RAM that was being utilized all at the same time on that.
And then minimum bandwidth recommendations for if I'm sitting in a cyber cafe. What's the lag hit?
You don't need a lot. You know, it's all HTTP and WebSockets. The most bandwidth you need is when you're doing a clone operation or a fetch. So that's your heaviest saturation. We don't work in an offline mode yet, but the actual communication between the client and the server is very small. So you don't, once you've got an active connection, you don't need a lot of bandwidth. Latency tends to hurt more than bandwidth. So if you're off in Sri Lanka, you know, the latency can have a bigger impact than the bandwidth that you actually get on it.
Cool. Very cool.
Very good.
All right. Thank you very much.
Appreciate you having us here today.
Thanks a lot, everybody. I really appreciate it. We're gonna do our usual routine now, where we strong arm people into giving talks in the future and give away a copy of IntelliJet. What else? Oh yeah, we have that special announcement.
Well, yeah. So a couple things today. One is Nebraska Code Conference. I know a handful of people in here already know about it, but that's in Lincoln in March. And there's quite a few people here actually that got the talks accepted to talk at the conference. I know Matt's one, I'm one, Seth, and a few other people.
Jessica, you got a talk accepted, and Sandy got a talk accepted, and are we missing anybody?
Yeah. And Scott.
Good.
Oh yeah, so that's in March, so definitely look forward to that. That's going to be a great time in Lincoln. Thanks to Tech Systems for the pizza and soda again. I think we skipped over that earlier. And then, so the big announcement is Aureus Group has very kindly found a way to get Venkat, super Java speaker Venkat, Supermanium from the No Fluff series, from Midwest JS, from UberConf, you know, all over the place. He's doing keynote speaking. He's going to come to Omaha and speak at OJUG in March. So it's going to be a special March session, March 2nd. So it's a Monday, so we had to fit in his schedule. And I think it's going to be at a different location to hold the crowd and things. So we'll send out some more information about that. So if you don't know him, look him up. You know, he's a big name in the Java community. He just spoke on Virtual Jug, a couple months ago, and Virtual Jug's next meeting has James Gosling, the founder of Java, on it. So Venkat's kind of, you know, a big deal in the Java community, so it'd be really cool to have everybody there, support him. We'll try and spread the word in the JavaScript community too. I've seen him speak before. He's really awesome.
It costs triple what tonight costs. Right?
Exactly.
Or maybe it's 100 times, because he's 100 times better than me.
Yeah, big point. So usually you got to spend big money to go see him speak on, you know, Groovy or Java, and we're going to kind of bend his talk into something that we're really interested in. So yeah, this is free.
That's awesome.
Yeah, it'll be a lot of fun.
So,
did I forget anything? Is there anything else?
Next month is, how do you say Joan's?
Joanne?
Joan's going to talk. He talked before on Angular. Next month, February, Joan's going to talk on Java security mixed with Angular. How do you put it together? And then after that, we're low on speakers. So if you have an idea for a lightning talk or a full session talk or half session talk, please chat with Jeff or myself or one of the other organizers like Juan or Ryan or Jessica. You know, it's all good. Some people tell me I'm scary sometimes. I try not to be. You know, we really want to hear what you have to say. We really want to hear what you're interested in. You know, let's all get together and help each other have more fun and be better. So speaking of having more fun, I hear there's something better than the Eclipse IDE.
And that is?
IntelliJet. And so, unfortunately, there's only 46 of us here tonight. So we can't give away 2. We missed it by 4 people.
So next time, bring a friend.
Yeah. So there's 8 tables, 0, 1, 2, 3, and so on. Yes? Ta-da! Survey says table 3. So 0, 1, 2, 3. It's like wishes come true. So someone in row 3, and there's 6 people in row 3, yes? I think.
0 to 5.
Which side is 0?
0 is over here. I'm a 0. Congratulations. Tell David, when did I eat or where you like it? So I think it's traditional for us to, if we want to, over at the DJ's dugout thing.
Yeah, DJ's dugout. Everyone wants to go.
You know, I for one like beer, and we did kitchen demolishing, and we assembled an IKEA cabinet, and we cut holes in it to match the hot and the water